Hello everyone. In this video, I will cover the section on the applications of systems of equations, which was the previous section, and now it is mixture problems are those applications of systems of equations. So let's look at this first example. Example 1 says, in chemistry class, James is required to mix 5 gallons of 10% acid with 10 gallons of 30% acid, and he comes up with some solution. Notice that he has 5 gallons, I always like to write my amount, of 10%, and he has 10 gallons of 30% acid solution. All right? 5 gallons of 10% plus 10 gallons of 30%. So I'm not sure what the final content's going to be, but I know at the end he has to have 15 gallons because he's adding together 5 and 10 gallons. I'm not quite sure what the final percentage is, but definitely since he's using more 30% than 10%, I would expect this value to be greater than 20%. Greater than 20%, because if I mixed 5 and 5, you would expect it to be exactly 20%, because that's halfway between 10% and 30%. So I haven't really solved anything, I've just got an idea of what's going on in the problem. So it says calculate the number of gallons of acid in the first solution. So how much of this 5 gallons is actually acid? The way I do that is by multiplying 5 times 10%. But remember, anytime you multiply a percentage, you always have to change it to its decimal equivalent, which is 0.1. If you don't remember how to change from a percent to a decimal, just take 10 and divide by 100. The percent symbol means divide by 100. So take 10, divide by 100 gives you 0.1. When you multiply the two together, you get 0.5. So you have half a gallon of acid in this 5 gallons. So 4.5 gallons of water and half a gallon of acid gives you a 10% acid solution. Now let's do the same for the second solution. It's going to be 10 times 30%, which is 0.3 or 0.30. 10 times 0.3 is 3. So we have 3 gallons of acid and 3.5 gallon of acid. So in the final solution, there has to be 3.5% or 3.5 gallons of acid. So of the 15 at the end, 3.5% of that is strictly acid. How much liquid is there in the total solution? That's 15 gallons. What percent of the final solution is acid? Well, the way you do that is 3.5 divided by 15, which equals, and I hit the Internet Explorer button. Let's do 3.5 divided by 15 equals, that tells me it's a 23.3, so a 23% acid, which definitely goes to my thinking that it needs to be closer to 30 than it is to 10, which exactly it is. Is the percentage of acid in the final solution 10 or 30? Is that what you expected? Yes, it is what I expected. Now, this is one way to come up with these values. Let's look at another example. Later in the week, Lanisha is required to mix 10% with a 30% to produce 200 gallons of 25%. So now we know the first two acid amounts, but we don't know the amount of liquid that they're used of each. But I know that these two have to total to 200 gallons. So if I was to draw a little picture down here, it would look like this. So this one, I don't know the amount, but this one is 10% plus some other amount of 30%, And it gives me 200 gallons of 25%. All right, let's answer question A. Do you expect to need more of the 10% or the 30%? Well, it has to be the 30 because our final solution is closer to 30 than it is to 10. Right, so now it says write an expression using x. In the previous problem, we would multiply amount times percentage. Now the amount is a variable, so it's simply 0.1 x, or 0.1 times x. The percentage times the amount. Same thing with the other one. It's going to be 0.3 times y. Now it says use your answers from B and C to represent the number of gallons of acid in the final solution. So I know when I take 0.1 x and I add it to 0.3 y, let me make this x a little bit better, plus 0.3 y, that gives me 25%. When I multiply 200 times 0.25, you come up with 50. So I know that when I add together the amount of acid in the first solution plus the amount of acid in the second solution, I better get 50 gallons of acid because my 200 gallon ending mixture is 25% acid. How many gallons of acid are in the final solution as an amount? So basically 50 is the answer to this one. So this answers part D and 50 answers part E. Since we know two different ways to specify the amount of acid in the solution, now what I'm going to do is I'm going to take this equation and I'm going to solve it for y and graph it. Okay? So we have 0.1x plus 0.3y equals 50. So we have 0.1x plus 0.3y equals 50. So now I'm solving for y so that I can graph the equation. So the first thing I need to do is subtract 0.1x from both sides. That gives me 0.3y equals negative 0.1x plus 50. And then divide both sides by 0.3. That gives me y equals 1/3 x, 0.1 over 0.3 is 1/3, plus 50 divided by 0.3 is 500 divided by 3. Just do it in the calculator. 50 divided by 0.3 equals 166.67. So we'll just say 166. So now let's interpret what this means. All right, graph the equation. So notice our y-intercept is 166.67. So that means when x is 0, so when I use no 10% solution, it takes this many gallons of 30% solution to have 50 gallons of acid at the end. So this is about right here. Oh, and I've messed up in one place. In the fact that, look, I lost my negative right here. So this is negative 1/3. So my slope is fall 1, run 3. So fall 1, run 3. So it's very, very minute in here because we're only falling 3 gallons, right? We fall 1 gallon and then run 3 gallons. So about right here. Then right here, then right here. Then right here. Now let's look, what is the x-intercept? So if I let y equal 0, what is the solution for x? So minus 1/3 x plus 166.67. So I would subtract this over, so I have minus 166.67 equals negative 1/3 x, which implies x equals, dividing both sides by negative 1/3. So I want 166.67. Remember, dividing by negative 1/3 is the same thing as multiplying by negative 3. So I'm going to take the number that's already in the calculator, or it's not in the calculator, 166.67, and it was negative, times negative 3. 3 negated. Let's do it again. 166.67 negated times 3 negated. 500. Which makes sense, because this value needs to be 500, because if I have 500 gallons of 10% solution, that means I have 50 gallons of acid. So you would connect these two dots, and there's that graph. So this is just kind of, a way to look at these problems to understand exactly what's going on. So along this line, if I take any amount of these two liquids, so I could take 175 gallons of 10% and 110 gallons of 30%, and it'll give me 25% at the end. So notice there's a bunch of values that make that statement true. Any 2 points along this line would yield me 200 gallons of 25% acid solution, or exactly 50 gallons of acid. So it says, how many ways can we add the first selection to the second solution? Infinite. Because I could take none of the 30% and 500 gallons of the 10%. Because that yields us 50 gallons of acid. All right? Okay, now, let's do another. So as I'm looking at this, so we want to have only exactly 200 gallons. So let me erase this answer. Let's think about what the question said. Now there's an infinite way to come up with 50 gallons of acid. There is not an infinite way to come up with 200 gallons of liquid. All right? So let me rephrase what I said in the previous statement. There is an infinite way to come up with this exactly 50 gallons of acid using these two mixtures. But if I'm only going to have 200 gallons of liquid at the end, there's only one way to come up with it. So let's go back and look at our values, starting right here. Looking at, using this, I'm going to create a system of equations to solve this problem. Because it's kind of hard to say, well, do I use, it's definitely not here, 0 and 166.67, because that's not 200 gallons of liquid. As I move this way, what about 50 and 150 there? That looks like exactly 200 gallons of liquid. But I'm not sure, because once again we're graphing. Maybe this line doesn't go exactly through right here. Let's look at another way to solve this problem. So solving it algebraically. So let's start with our picture. This is how I want you to do all your mixture problems. Okay? This one shouldn't go all the way through, it should only be here. So, remember, this is x and y and 200. The top is the amount, M-O-U-N-T, and the bottom is percent. Acid. So this one was 10%, this one was 30%, and this one was 25%. So let's consider our first equation that we built, the 0.1x plus 0.3y equals 50, which is these two multiplied together. Now our other equation is looking at us right here in the face. Our amounts, x plus y equals 200. So that's how we'll set these problems up. One equation will be your amount, The other equation will be these two things multiplied together. So x times 0.1 plus y times 0.3 equals 200 times 25%. So this was the equation that I graphed before. And then if we went to intersect it with this equation, notice what this becomes when I solve for y. Y equals negative x plus 200. Let's draw this line, negative x plus 200. So 200 is the y-intercept. Let's look where the x-intercept is. So if I let y equals 0 equals negative x plus 200, where's my other one? I would subtract 200. So then I get negative 200 equals negative x. So x equals 200. So my intercepts are both 200. And then if I connect these two lines, this is where my solution is. So even though there's an infinite amount of ways to come up with 50 gallons of acid, there's not an infinite amount of ways to solve this problem. And as you can tell, if I draw this by hand, I can't tell exactly where these lines cross. So that's why we have algebraic methods. Now let's come back to here. So now we need to ask ourselves, we can't solve this system by graphing. We already tried, but it's too hard to do it by hand. It's easy to make mistakes. So now we need to use either elimination or substitution. Which one do you want to use? Well, since this is already lined up and I just need to multiply this by negative 0.1 and I can get canceling, I'm going to use elimination in this method. I could move the x over and plug it back in. Substitution is perfectly fine to solve this problem, but I'm going to use elimination. So I'm going to multiply this by negative 0.1. Same with this side, negative 0.1. So let's write my first one, 0.1x plus 0.3y equals 50. Now let's do this. So we have negative 0.1x minus 0.1y equals negative 0.1 times 20 is negative 20. And then add them together. So those cancel. 0.3 minus 0.1 is 0.2y equals 30. Divide both sides by 0.2. And y equals 15. No, let me look at that. I'm multiplying there. 30 divided by 0.2. Ooh. 30 divided by 0.2 equals. See, 150, I was off by 10 because I tried to do it in my head. That's why you always use the calculator on this stuff. So y is 150. So if I come back in and look at this equation, if y is 150 and when I add the two together it equals 200, that means that x must equal 50. Which is what I guessed by looking at the graph, but now I algebraically verified my solutions. So, your assignment for the mixture problems. Let's get here to the bottom of page 25. Choose 3 of the application problems on pages 23 through 25. Solve each of them on your own paper. So you're going to have an assignment that you have to do in Microsoft Word, or you can use write it on your actual paper, scan it, and email it to me. It's probably easier just to do it in a Word file, then you just have to save it and email it to me. All right? So you have 2 assignments. Then you have this mixture problems assignment in my math lab. Now I want to look at this to explain a couple things. So we have some mixture problems. So go through them the same way. I'll show you one more example. This one is a lot like the problem we just did. And you're going to see these a lot throughout the semester. These turn-in portions. This problem I'm not making you turn anything in. But I do want you to answer all the questions. Notice here at the bottom it says draw a graph of the 2 equations, label your axes. I'm not making you do that for this specific problem, but in the future I will require you to do this. You could draw this graph in Excel and give it to me that way. The reason I'm not making you do it with this assignment is you don't know how to graph in Excel yet. So what I'm going to do, the next video I'm going to make is graphing in Excel. So then from that point forward, you will be able to graph. So you can do this by hand stuff using Microsoft Word and Microsoft Excel and then email it to me, rather than do it by hand, have to scan it onto a computer and then email it, which is a little bit more trouble. Okay? So what I'm going to do is kind of step through problem one. I'll help you set it up and show you kind of how I want you to solve it. So you have to pick 3 of these 5 application problems. I'm going to help you set up application 1. So it's a mixture problem. You know, even if it's not acid, these investments you can set up exactly the same way, these investment problems. All right. So we have, how much pure alcohol? So what's the percentage of pure alcohol? Well, it's 100%. Should be added to 100 liters of 10% alcohol to create an 80% solution. So we're mixing 100% and 10% to create an 80%. What do we know as far as volume? It says how much pure should be added to 100 to create 80. So we don't know how much pure. We do know how much of the 10%, there's 100 liters. So my final amount has to be x plus 100. These two amounts added together. Once again, it's amount versus percent alcohol. Okay? So your 2 equations are your top level. Well, in this case, you don't have 2 unknowns, so there's not 2 equations. This one, there's only 1 equation, because you don't have an x and a y. Really, you could have called this y and said y equals x plus 100. So really, you could erase x plus 100 and just call it y, but why would you want to do that? Just have one variable here. So now we have this times this plus this times this equals this times this. Pretty simple stuff. Then, to answer the question, all you need to do is go to a Microsoft Word, or you can download Apache OpenOffice. OpenOffice, if you don't have it, I'll type here's where you can get an OpenOffice file. It's all free. And the nice part is you can save files in DOC format, in document format, and email them as Microsoft Word. Boom, right there. Download now. Free replacement for Microsoft Office. Excellent program. So what you do is you open up your Microsoft Word. So then you would put, type your name, Matt Bell, mixture problems, and then type in which problems you're doing. So here's problem 1, and then just you don't have to do all the work. Just tell me how much pure alcohol you would mix. So basically, I want you to restate this question. So I want you to put, I would mix blank percent blank liters of pure alcohol with 100 liters of 10% alcohol to yield blank liters of 80% alcohol. So this number is going to be what your x is, this blank, and then this one is going to be x plus 100. Right? So that's really all I need for your solution. So just just answer 3 of these problems. Work them out and give me what the answer is, where you restate the question. Okay? And those are due to me. These 3 application problems, along with the homework, are due 6:27 at midnight. And remember, I am not requiring you to do the graph from my math lab. You don't have to do the graph. Notice I haven't put anything in here as far as turn-in problems. So the only problems you have to turn in for this portion is 3 of these 5 application problems. And you can turn them in a Microsoft Word format. You know, save this file and then email it to me. All right? Well, you know, if you guys have questions about this mixture problem stuff, let me know. There's some other ancillary sources. Here's Khan Academy. You know, type in Khan Academy and it pulls up khanacademy.org and have the search bar right here. Type in systems of equations. You don't have to sign in. Systems of equations, here's all this. Old video, solving systems, super fast systems of equations, solving linear systems by graphing, solving by substitution, solving by elimination. So here's more videos to help you with this topic. I will post this video to your Google Plus circle and attach it to your homework assignment later on today. Thank you everyone and have a wonderful day. The last video I will produce tomorrow, which covers this graphing in Excel, which doesn't take very long at all. So the video will be pretty short for this one. I might make it this afternoon, I'm not sure. And then we're done. And your Unit 2 exam. Make sure you click your Show All and View All on one page button. Your Unit 2 exam, notice here, is due 6/29 at midnight. So I've covered up to this portion. So there's really only this one assignment, fitting linear models to data, which I'll produce that video in a little bit. All right, everybody. Thank you and have a wonderful day.